Okay, for this reaction, we are doing an ozonolysis followed by an oxidative workup. Ozonolysis basically cleaves alkenes to give carbonyls. And we have two carbonyls here. This is saying it's a sole carbon containing product, so that likely means these two carbonyls were linked. And so if we were to number, we get a 5-membered ring. So our product, because we counted to 5, we get a 5-membered ring. With the alkene going between carbons 1 and 5. And then we have a carbon off of 1. We have a methyl group off of 2, a methyl group off of 3, methyl group off of 4, and then 5 is a carboxylic acid. The carboxylic acid is formed from this, so that would have to have been an H. This molecule here is incorrect because this molecule is an enol, and it would rapidly become this, which ozonolysis does not work on. So therefore this is the incorrect structure. It needs to be a hydrogen right there. Now, the hard part about this question is figuring out the stereochemistry of those methyl groups. And one way of going about it is figuring out R and S. When you do so, let's take a look at our starting material. I'm going to use the numbers in red. Let's start off here. This atom is 1. This is 2. And this is 3. Okay, when you do this, well, hang on, we'll just go ahead and do these all. So this is an R chiral center. Excuse me, I always mess this up. That's an S chiral center. 1, 2, 3. And then we do this one right here. 1, 2, 3. That is an S chiral center. Now if we do this one, 1, 2, 3. That is an S chiral center. Okay, all 3 of them are S's. Now, when you're using R and S to figure out what your starting material are, it's vitally important, and this is where most people mess this up. You have to keep the same priorities in your product as in your starting material, regardless what the actual priorities are. For example, 1, so when we're doing the chiral center on carbon 2, carbon 1 has the highest priority, the methyl group has the lowest, and carbon 3 has the next highest. I'm matching those numbers up to the original ones. So here, let's see a different color. One, 2, 3. 1, 2, 3. Those are the same priorities. And I know it has to be an S, So 1, 2, 3. In order for that to be an S, your thumb needs to be going inside, going towards the screen, or straight down. That means that methyl group then is a wedge. Now when we look at the next set of priorities, on carbon 3, carbon 4 had the highest priority. Carbon 2 had the next highest. And carbon 3, the methyl group, had the third. Not carbon 3, but the methyl group. Okay. And so when we figure out, we're going to get an S chiral center again. 1, 2, 3. In this case, our hydrogen must be coming towards us, so it's a wedge. That means that methyl group is a dash. Please note that if you were doing the priorities based off of what the structure of the starting material were, 1 and 2 would have been swapped. It's because technically the higher priority is that carbon. On the starting material. But when you do the reaction and cleave this, the higher priority switches to carbon 4 because of this group. That's why it's vitally, vitally important that whatever priorities you use in the product, you're using in the starting material, regardless if they're actually the same, regardless if they're actually the real priorities. Last one. This has the highest priority. That's 1. Next is this one. Next is this one. 1, 2, 3. And again, we're looking at an S. The hydrogen would be coming at us to go from the 1 to 2 to 3. That would make that methyl group then a dash. So the final product would be cyclopentene, like that. Methyl group as a wedge, methyl group as a dash here, methyl group as a dash there. If you want to double check this, what you could do is take your starting material and do the ozonolysis. And redraw it so that it's in the same conformation. The only difference is instead of a double bond there, you've erased that, replaced it with a double bond O and double bond O, OH. And then when we number it, 1, 2, 3, 4, 5, and figure out R and S on this, This one right here is an S chiral center. This one right here is an S chiral center. And this one right here is also an S chiral center. That matches that.